Welcome back to the YouTube channel. Today, I'm going to just teach you how to solve a single variable equation. So this is going to be algebraically and graphically, and our example equation is just a simple 2x minus 6 equals 7x plus 4. Because this is just a little introduction, it will get more complex as we go on. So 2x minus 6 equals 7x plus 4. What do we want to do first if we are solving for x? Well, first we want to get x on one side and then these normal numbers on another side. So we could subtract 2x from both sides, or we could subtract 7x from both sides. I'm going to subtract 2x from both sides. So minus 2x minus 2x. This will be negative 6. This negative 2x and 2x cancels, equals 7x minus 2x plus 4. I'm going to simplify this 7x and 2x, negative 2x, to 5x. And then what do we do next? Well, we have this 4 on the right side, and we want to move it to the other side because we want to isolate this x value. So we're going to subtract 4 from both sides now. Just do the inverse of plus 4 is minus 4. So subtract 4 from both sides to keep the equation equal. The 4 and the minus 4 cancel. So negative 10 equals 5x, because negative 4 minus 6 is negative 10. So what do we do now? Now we have negative 10 equals 5x. Well, to isolate this variable, we're going to take away the coefficient by dividing by it. So instead of 5x equals negative 10, now it's negative 10 over 5 equals 5x. And what does that come to when we simplify? Negative 2 equals x. 5 divided by 5 is 1. Negative 10 divided by 5 is negative 2. So that is algebraically. Now is graphically. So we're doing the same two equations. Here in red is 2x minus 6, and in purple is 7x plus 4. So the graph's a little janky, but I think you get the idea. You plot some points. So here I know the y-intercept is 4. So when x equals 0, y is 4. So first, we're going to change this into two equations. Y equals 2x minus 6 and y equals 7x plus 4. Because that's basically what we're saying here. We're saying these equations are equal, and if they're both equal to y, therefore they are equal to each other. So we are going to try to find now their intersection point. This can work with graphs of any equations, but right now we are just going to use two lines. So this y-intercept is negative 6. So when x equals 0, y equals negative 6. So 0, negative 6 would be on here. Then this purple equation, when x equals 0, y equals 4. So 0, 4 is on this graph. So now, what do? Well, we keep plotting points. And down here, you'll eventually see there's one intersection between the lines. Lines can have one intersection, no intersections if they're parallel, meaning they have the same slope, and infinitely many intersections if they are the same line. So here at this intersection point, we see it, right? Now we just count. We circled it. Now let's find it. So we could count in the y's here, and we could go 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever. My hash marks are hard. I think that's a negative 10. But here we are just solving for x's. There are no y's in this original equation. In the original equation is what we're solving for. And I can see here 1, 2. Well, this is a negative 2 to the left. So I can just say x equals negative 2. So that's the same answer as our algebraic. Some may be easier to just graph. Some equations will be easier to graph and find the intersection point, while some will be a lot easier algebraically. This equation, I'd say it's easy both ways. You get a nice, good x equals negative 2. So, thank you for watching. That was a quick introduction to single variable equations, just solving them. Thank you for watching.